Hi, in this class I would like to explain about how to get the Z parameter for two-port network. So by looking at this example, we can do calculation. I will show you using mesh analysis to get the impedance parameter. Remember that this is the impedance for Z11. This one is impedance Z12. This one is impedance Z21. This one is impedance for Z22. So you will find these 4 impedance parameter for this two-port network circuit. By taking this one as a V1, we put the polarity for voltage V1, and this one is V2, so we put the polarity here, and this one is I1 current through here. This one is I2 current. So by using mesh analysis, we can label like this. This one is I1 going to the loop 1. This one is I3. I'm going to use I3 because this one we already have I2 going this way. So I2 in the opposite direction like that. Okay, for loop 1, by looking at this, so this one is loop 1. Okay, for loop 1, negative V1, which is from here, current flow, plus 4 ohms times I1, which is 4I1, plus 8 ohm times, for this one, it's shared between I1 and I3. So by looking at I1 loop first, we take I1 minus I3 equals to 0. Alright, V1 is equal to 4 I1 plus 8 I1 minus 8 I3. V1 equals to 8 plus 4 is 12 I1 minus 8 I3. We consider this one as the equation 1. Now we look for loop 2, which is loop 2 is over here, loop 2. Okay, for the loops 2, if we start from here, the resistance over here, so 8, it share between I3 and I1, so I3 minus I1 plus, so it's going here, 6 I3 plus, and then it's made the resistance 2 ohm. This resistance 2 ohm is sharing between I2 and I3. So you got 2 I3 plus I2. Why plus? You see the direction of the current I3 and I2, they are inside the 2 ohm resistor. So you have to plus them, equals to 0. So from here you got 8 I3 minus 8 I1 plus 6 I3 plus 2 I3 plus 2 I2 equals to 0. So you see how many I3 you got over here. So you got 16 I3 minus 8 I1 plus 2 I2 equals 0. So this one is considered the equation number 2. Alright, now we go for the loop 3. Loop 3 is over here, is loop 3. So the current I2 is flow through resistance 2 ohm and is shared with I3. So we're going to write as negative V2 plus 2 I2 plus I3 equals to 0. So V2 is equals to 2 I2 plus 2 I3. So this is equation 3. Okay. Now you got 3 equations. You must have only I1 and I2 for 2-port network. For 2-port network like this, you must have only I1 and I2. So we need to simplify I3. If by looking at this loop, we can simplify I3 from here. 16 I3 equals to 8 I1 minus 2 I2. I3 is equals to 8 over 16 I1 minus 2 over 16 I2. I3 is equals to 1 over 2 I1 minus 1 over 8 I2. Okay, we call it as equation 4. We refresh back for the loop 1. You got V1 is equals to 12 I1 minus 8 I3. For the loop 2, you got I3 is equals to 1 over 2 I1 minus 1 over 8 I2. This one is equation 4. Remember that? For the loop 3, you got V2 equals to 2I2 plus 2I3. This one is equation 3. So you can add equation 4 include equation 4 into equation 1. V1 equals to 12 I1 minus 8 times I3 is equals to 1 over 2 I1 minus 1 over 8 I2. So it's equal to 12 I1 minus 8 over 2 I1 minus plus 8 over 8 I2. So you simplify this, where you get 12 minus 4, which is 8 I1 plus I2. Okay. So you got V1 equals to 8I1 plus I2. Okay, we call it this one as equation 5. Okay, you can get the impedance, which is this one is represent for Z11. This one is Z12. So for this impedance, you can put 8 and 1. Okay. We go to V2. V2 is equals to 2I2 plus 2I3, which is I3 is 1 over 2 I1 plus 1 over 8 I2. So from here you got 2I2 plus 1I1 plus 2 over 8 I2. So this one you simplify 1, 4. So you got this one is minus. So you got 3 over 4 I2 plus I1. So if you rearrange back, we got V2 equals to I1 plus 3 over 4 I2. So this one we call it as equation 6. So this one for V2 is Z21. This one is Z22. So you can put it here as 1. This one is 3 over 4. So that is your impedance. That's all. I hope that it will help you for your study. Thank you.